and welcome back to my R tutorial series. This is, of course, episode 3, and today I'm going to talk to you about data frames and how data is organized within R. This will lead into a discussion of how to use Excel to get your data in R, which is probably the more common way to do it. But in this episode, I feel like it was a logical jump from vectors to making data frames from scratch and then manipulating them. And then we can talk about how your data might come in from a different setting into a similar format, just in a different method. So today I'm going to talk about data frames and how to set them up from scratch. So what is a data frame? Last episode, we talked about vectors and how they're basically just a series of individual values compiled into a single object. Remember also that vectors are objects of the same class. They all have, each item in the vector has to be the same type of class. A data frame is basically the same thing as a vector is to a single object. So even though they're technically objects of their own, I like to think of them a little bit differently. Just to clarify that kind of setup. So a data frame is a two-dimensional vector. There's columns and rows. And they're technically made of vectors. If you take a single row or a single column, usually single columns, you can operate them as if they were a vector. You make data frames from scratch by taking vectors and putting them together. This is the closest comparison you can make is to vectors. Thing about data frames is you can have vectors of different classes put together as separate columns, and it will still function as one object in a data frame. So that is super useful. There's lots of uses for them. They tend to be a lot more commonly used than matrices, which are what you might think of as their little sibling. A matrix is a lot like a data frame, except it's typically limited to numerical objects, and their uses are a little bit more limited. They have a little bit less functionality. They're useful if you need to save an output, like, say, from a for loop, as a two-dimensional space. So we'll talk about that when I talk about for loops in some later episode. But we're just going to stick to data frames because they tend to have a lot more functionality, and pretty much anybody who's importing from Excel is going to import as a data frame anyway. So we have that functionality. So, like I said, there are multiple ways to get a data frame, and I'm just going to focus on starting from scratch here. We're just going to take some vectors that we'll make and then put them together. And that will it's a little bit more tedious than using Excel, but it shows you more of the structure of how the code works and how data frames are actually made and what they're used for. So, I think it will be a better way to explain the structure and the background behind the code to start with. And then we'll get into the more applicable Excel usage. So to start, we need some vectors. So just like last time, I'm starting with a fresh R Markdown to hopefully have the repetition help you remember how to do things by seeing me do it multiple times. So I'm going to create a code chunk to work in. So again, that's Control-Alt-I, or you can hit the Control or the chunk button up here and select the R option. So, for example, I'm going to make a little grade book as if a teacher is teaching something and has some grades for some students. And this is obviously just a very simple grade book, but so I'll have a column of names, or a vector of names, and a vector of their scores out of 120 points. We're going to pretend that this assignment is out of 120 points. And you'll see why I did that in a few minutes. So I'm going to start by making some vectors, and we're just going to call the first one name. So again, you just start with the name of your object, the assignment operator, and then we're going to concatenate because we want a vector with the C command. And I'm just going to put in some of our names because why not? So I'll start with mine, and then let's say Kelsey, and then Carlos, and then Christian, and then Camilla. How about that? And 5 should be plenty. So I'll make that object. So now we have a character vector called name with 5 names in it. And then I'll make one for score. And again, we're just going to concatenate into a vector, but this time it's going to be numeric. So we're just going to use numbers. So we'll say this is out of 120, right? So I'm just going to put random grades here. So let's say I got 110, Kelsey got 112, Carlos got 111, Christian got 114, Camilla got 110 as well. We'll just say that. We all did pretty well. Not too bad. Now, so this is technically all you need to make a data frame. You really only need 2 to make it, more than a vector. It's 2 vectors put together. You can make it as many as you want, of course, but I'm just going to keep it simple for now. So, to make a data frame, you kind of make it like you're making any other object. You give it a name. I'm just going to call it df because that's simple enough. And then the assignment. And then the command is just data.frame. And then in parentheses, so here you just put the vectors in, separated by commas, in the order in which you want them to appear as columns. So each vector will be its own column in the data frame, and they'll appear in the same order. So we want the name vector to be first, and then the score will be the second column. Now, again, you can put spaces or you don't have to in this command, and then these do not need to be in quotes because you're referencing objects. So these are not strings like in the vector. They're objects that are outside of the vector, and therefore they're not strings. So keep that in mind. So if we make this, oh, I didn't make the score object. That's my bad. So make the score object and then make the data frame. So if we click on the name df up here in our environment under data, if we click on df name, it will show our table. So this is our data frame right here. 2 columns. Note that the columns are named the same as their vectors were named. That's a pretty important thing to remember. And then they're in the same exact order that I put them in originally. You'll notice also in the environment, just for reference, this shows 5 OBS, which I think stands for observations. And that is just how many rows or data points you have out of 2 variables, which would be your columns. So 5 rows, 2 columns. You can also click on this little blue icon here next to the data frames, and this is just a different way of showing you the same information. So it'll also show you the class. It kind of shows you the structure of the vectors, actually. It shows you that you have a character class vector and then a numeric class vector, and it shows you the values. This view is a lot more important when you have something that's less discrete than a data frame with subclasses, etc. But for now, that's all you need to know. So this is a separate tab. We can go back to our code here. And alternatively, if you wanted to open this pane without trying to, let's say you have like a ton of stuff up here and you don't want to have to try to scroll to it, you can also use in the console, you'll see it's already run it by me clicking on the name. You can use this view command. Note the capital V. I don't know why it's capitalized. Almost nothing else is, but it's capitalized. So if you type that, it'll pull up this tab. So that's good if you have like a ton of stuff up in your environment, which I recommend cleaning up your environment whenever you possibly can, especially with this broom icon, especially if you're not going to use it anymore. So anyway, we have this data frame now that has name and score for 5 people, and the score is out of 120. Now this name does not really specify that, but by itself, it's not that much of a problem. So let's make it a problem so we have an excuse to change the column names, which we can do. We can also change row names, which you don't usually want to do, but you might have a reason for it at some point. But let's make it ambiguous. Let's make it a little bit confusing and give us a reason to change the name. So I made this out of 120. Let's say the professor needs to change the grades to be out of 100%, right? So they actually have to apply some math to this to make that if they don't want to do it by hand. And to do that, we need to know how to reference an individual column in a data frame. Now, you could do this with the score vector that I made in the first place, but let's pretend you don't have those vectors. Let's pretend that you did bring this in from Excel and you don't have the individual objects that make up the columns. Let's do some math with matrix notation. Matrix notation is how you reference individual pieces of a data frame, whether that's a full row, a full column, or just pieces of each. And to do that, you just take the name of the object, so that could be the data frame, in this case, df, and in square brackets, directly after, no space or anything, no assignment variable or operator, just brackets right after the name to reference it. You can save this as a separate object if you wanted to, like, oops, if I can type. You could do this if you wanted to save what you're getting out of this, but I'm not going to. And in here you put a type of coordinates. So they're technically backwards from like the normal XY coordinate system. It's actually YX. But if you think about it as row column, that makes a little bit more sense. So it goes row first, then column. So let's say I want the second row and the second column. So I'll end up with getting Kelsey's score here. So that would be 2, 2 in the matrix. You always separate them by a comma. So if you do this, you get 112, which is exactly what I said you'd get, 112. Let's say you want Camilla's score. That would be row 5, column 2. Let's say you forgot this was Camilla's score and you want her name. You'd get 5, column 1, and it'll show you that. Let's say you want the whole column of names and not the scores. You can just leave the row blank, either with a space or without one, but you still need the comma. And you can say you want column 1, just all of column 1, and you'll get all 5 names. You can also do this with rows. If you just want row 1, but all columns, it'll show you this. And if there's more columns, it'll show you all of them, or as many will fit anyway. But you get my name and my score. So that's how you reference it. Just kind of briefly, I'll give you a little more detail at the end of the episode on that. But let's let's say we want to take this column of scores and make it out of 100%. So to do that, we need to first, we can make it its own vector. That will probably be the easiest. So let's say grade. So this is our percent grade. And you can say we want the second column of the data frame. So all the rows, just the second column. And since it's a numeric vector by itself, just like the score vector that we made, you can actually do math to it. And it will do the math function that you give it to each individual part of that vector, each individual member. So for each row in the second column, for each score, we want to divide it by 120 to get the 100, or the percent out of 100. You can also use spaces here if you want or not. Doesn't matter. We'll give you the same thing. I like spaces. So grade. And then if I look at grade in here, you get all these decimals. Now, usually you want that to be the percent version and not the decimal. Maybe you don't. I think it'll look better as a percent, so I'm going to overwrite grade with itself and just multiply it by 100. So now I've overwritten this version of grade with one that is itself times 100. So now if I look at grade, it's the percentages. So look at that. We all get A's. We're amazing students. I have no idea what class this is for. This is just some BS I've come up with. Anyway, so now we can take this and we can append it as a new column into the data frame. So to do that, we can simply overwrite the data frame as a new data frame by including the data frame itself, the original one, so that we're not actually getting rid of anything. We're just adding to it. So you have the original thing plus the new grade column. And again, these don't need to be in quotes because they are referencing objects that are already created. And boom. Now we have a grade column. Okay, so score and grade are kind of ambiguous That was kind of my point. You don't know, what does this mean? What is this out of? Is it weighted? Is it, percent? What is it? You wouldn't know just by looking at it if you were not familiar with the setup of this grade book or this class or whatever. So let's change the column names. To do that, we basically just have to pretend that the column names are their own character vector. And there's two different ways we can do this. We can either make a vector of names for the columns, or if we want to save ourselves an object that would take up space in our environment, we can just kind of make it as we go. And so for this we need the call names, C-O-L names function. And in here we're altering the column names of the data frame df, and we're going to assign these new names via as if we had a character vector with the concatenate command. So we have to do all of them at once. I have not found a way where R will let me only do several of them, but not all of them. So if you know of a way, let me know. But I've tried using matrix notation on this, and it's always a little bit glitchy. I know you definitely can't do just one at a time, or at least any of the ways I've tried it hasn't worked, but maybe there is a functionality to do that. So I tend to try to avoid naming a lot of columns at once, because even if you're only renaming one, you still have to put them all in. So at least in this method, the way that I know how to do it, you have to rename all of them. So I'm just going to say name. Name can stay the same. And then we'll say score.120 to indicate that it's out of 120. There's probably better ways to do that, but that's fine. You could do grade percent or percent grade or grade.100. I'll just do that for consistency. And then that's all you need. Just run that command and your column names are changed. So now it's a little more clear. On larger data sets, you don't necessarily have to do this, but you'll probably have a bunch of funky names anyway that you would have metadata for, and the metadata document would then explain all your naming systems and your measurements and your units and everything like that. So no biggie. But this is just for organization and renaming functionality, just so that you know exactly how to do it. You can also do this with row names if you happen to want to name the rows. So you could say row names of df, and then do that. You need 5 of them because you have 5 rows here. Now let's, maybe functionality for that would be like our student ID numbers or our email usernames or something like that. But I tend to find it easier to simply make that their own column. So if you had student IDs, I could make a column of student IDs. And then, because you can't do anything with row numbers or row names, they are literally just there. You can do matrix notation with them. Other than that, though, they're just there. They just look like something. They'll show up if you make this into a table for your document, but that's about it. If you make it a column, then you can actually sort with them. You can subset by them. You can count them. You can do all kinds of stuff. So I'll talk more about that in a future episode, but just know that I would recommend, instead of row names, I would recommend just making your own column, even if you're planning to sort by them. So on that note, if you're renaming columns or rows or you're adding vectors to each other or to data frames, you do need to know the dimensions of them. You have to make sure that if you're adding a vector to a data frame like I did, you have the same number of items. Now, if you're using an existing column to do that, then it will automatically do it for you. It'll automatically count them and make sure that it operates on all of them, as much as it can anyway. If you're making one from scratch, though, you need to know exactly how many of whatever you're adding you have so that you can add the same amount. So like with the column names, I knew that there were 3 columns that I wanted to rename. If you leave them out or you add extras, R will get mad at you and won't let you do it. So to make sure that you know what you're doing, maybe you're working with somebody else's data, or you just can't remember because you have so many objects going through your head that it's just getting confusing. That happens when you have really big documents. Perhaps you just need to check with code. And you can do that with for vectors, it's the length function. So let's say I want to know how long the grade vector was. And there's 5 items. Or like, let's say I forgot how many students I had. length of name, also 5. For data frames and matrices, you can do dim, which stands for dimensions, and dim of df, it'll give you rows and then columns. So 5 rows, 3 columns. That's exactly what we have. I think you can also apply the class command that I showed you in the last episode. You can do that for each individual column. You can also say as dot whatever for an individual column because, again, columns and data frames function like vectors. So they're basically the same thing. They take the same commands as vectors in, I think, almost every case, most cases at least. So now you know how to do math with vectors. You can look at a data frame and rename things and kind of sort things. Now I'm going to show you a little bit more of matrix notation and some other ways to reference parts of data frames. So to do this, again, we can use the brackets method, the matrix notation method, by having these square brackets. Now let's say you want to access multiple rows, but only a single column. Or vice versa, multiple columns and a single row. Or let's say you want to move things around in your view so that you can view them out of order. Or you want some non-consecutive rows or columns. You can view them in whatever order you want, and then you can also save that as its own object. So for anything I do here, you could save this as its own object. Or you don't have to, you can just view it. So by running this command, so let's say I want to view the first, third, and fifth students. And I'll just look at all 3 columns. To do this, for each coordinate, you can use the concatenate command within the coordinate. So if I want 1, 3, and 5, I just need to separate them by commas within the concatenate command. And then I'm just going to view all the columns, so I'll have a blank here. There you go. So this is row 1, 3, and 5. Me, Carlos, and Camilla. Our scores and our grades. Now let's say you only cared about the grades. You don't need the scores anymore because you've already calculated the grades. I'm just going to copy this down. You can take this and you can make it C1, 2. And you can do that. And now you just have 1 and 2. So this is rows 1, 3, 5 and columns 1, 2. Now let's say you want to access only rows 2 and 4. Actually, let's do it this way. Let's say you want rows 2, 3, and 4, and just column 1. So if you want to do a range of numbers or a range of something in the concatenate command, you can use a colon to do so. So you want 2 through 4 with a colon instead of a comma, which would, if you gave a comma here, this would just be 2 and 4. But in this case, you include 3 by having the colon there. And then you just want column 1. Let's just do that. So there you go. Now you just have the names of 2, 3, and 4. Or let's say you want, columns 1 and 2. You want their scores. There you go. Or you only care about their grades, which I realize I did that backwards. But let's say you only care about their grades, so now you have their names and their grades. You'll also notice there's a lot of decimal places here. I'm going to show you that in a near future episode on how to work with numbers in more detail. So we can work on rounding these out or getting rid of the decimals. But we'll just leave them there for now. So there's one other method I want to show you to work with data frames before I close out this episode. So just bear with me. There's what I call R shorthand notation. I don't know if that's the official name, but that's what I've heard it called, and that's what I call it. And that involves taking the name of the data frame to reference something. And it's the same functionality as the matrix notation, it's just set up a little differently. So you can take the name of the data frame and you put a $sign after it. And then with that you can reference columns, but only columns. I don't think you can reference rows in the same way. So you can do a column. Let's say you want to access, you can only do one at a time too, I think. But let's say you want to access the names column. So df name. That will give you all the names. You can access specific rows from name, but only that one column. So you can do df $name, and then in square brackets, then you can just put one coordinate for whichever ones you want. So let's say you want 1 through 5. Well, actually, we'll just say like 1 through 3. You just need the one coordinate. So actually, I think you do need the C. You may or may not need the C there. Let me see, actually. Nope, you don't actually need a concatenate here, I guess because it's only one coordinate. So you get names 1 through 3, or you can do, 2 through 5. There you go. So this can get kind of confusing because you can actually use it to like subset and break up your data frames, and it gets rather complicated, but it is a faster way of typing out multiple commands sometimes, so this notation might come in handy later. So we'll keep that in mind, but that is just another way that you can reference your data frames, and I find it useful pretty frequently. So that's all for this episode. Again, next episode I'm going to show you how to work with Excel and getting data into R. We'll start actually talking about packages too, because you need a package to do that. And yeah, I think we'll just talk a little bit more about data organization and data frames. So thanks for watching.